Hi, I'm Ms. Hearn. Let's get started. In this video, we're going to talk about systems of linear equations in two variables and their applications. One of the ways that you know that an application problem might require a system of linear equations to solve is if you have more than one unknown. For example, in item number 1, we have at a fundraiser for a school band, volunteers sell hot dogs and potato chips. Patrons pay $2 per hot dog and $1 per bag of chips. A total of $140 is collected for selling a total of 88 items. How many hot dogs and how many bags of chips were sold? So there are two unknowns, the number of hot dogs and the number of bags of chips. So let's call the number of hot dogs X, and let's call the number of bags of chips Y. It doesn't really matter, we're just going to pick two variables. And then there should be if you have two unknowns, there should be two relationships given between the two unknowns. So one of them is pretty straightforward because we know we're selling a total of 88 items. So we know that the number of hot dogs plus the number of bags of chips has to equal 88. But the other relationship is a little bit more complicated because it involves money. We do know that the total price for the hot dogs plus the total price for the bags of chips has to equal the total amount collected. But we have to think about how do we write the price paid for the hot dogs. And when I say price, maybe I should say sales, because we're not talking about the price of an individual hot dog. We're talking about the amount of money collected because of people buying hot dogs. So the sales for the hot dogs, if each hot dog is $2 and there are X hot dogs, how do we figure out the total amount of sales? Well, for example, if we sold 10 hot dogs at $2 per hot dog, we would multiply 2 times 10 and get $20. So since we're selling X hot dogs, it's going to be $2 times whatever quantity X was sold. Similarly, for the chips, the total sales is going to be $1 times Y. And that equals the total amount of money collected, which is $140. So that's our second relationship between X and Y. So when you take the two relationships and put them together, you have a system. You have that both X plus Y equals 88 and 2X plus 1Y, or just 2X plus Y, equals 140. Now there are a couple of different methods for solving a system, which we've discussed, which are solving a system of linear equations by graphing, which we definitely don't want to do most of the time, only when I ask you to. And there's solving a system of linear equations by substitution. And then my favorite is the addition method, often called the elimination method. So I'm going to use the addition method. And with the addition method, what you want to do is to add the two equations together, and you're looking for one of the variables to cancel. In order for that to happen, the coefficients of the variables have to be opposites. So if I call this first one equation 1 and this one equation 2, equation 1 added to equation 2 doesn't make any of the variables cancel, but what I could do, for example, if I wanted the y's to cancel, is multiply equation 1 by -1. This is going to give y a negative coefficient, and then if I add the equations together, then I will see something cancel, the y cancel. So let's go ahead and we're going to take -1 times equation 1 and add it to the current version of equation 2. So -1 times equation 1, you have to distribute to both sides of the equation in every single term, will give you -x minus y equals -88. We're going to leave equation 2 the way that it is, 2x plus y equals 140. Okay, and then we're going to add the two equations together. It's important when you do this that the x's and y's are lined up and the constant terms are lined up, which is what we have. So add the two equations together. 2x minus x is going to be just 1x or x. The y's are going to add up to 0, so I don't really need to write that. And then let's see, what's 140 minus 88? 140 minus 90 would have been 50. We have 2 more than that, so x equals 52. Then once you have one of the values for one of the variables, you can plug it back into either of the equations to get the other one. The simpler equation to plug into is probably x plus y equals 88. So let's do that. Here's x plus y equals 88. We're going to plug 52 in for x. So if 52 plus y has to be equal to 88, subtracting 52, we would have y must be equal to what? Let's see, 36. Okay, so now at the beginning, notice that I made a little note. I wrote the x next to hot dogs and the y next to bags of chips. That was on purpose because I want to be able to remember what the heck x and y represent. So we just figured out that we need to get, we sold 52 hot dogs and 36 bags of chips. So this is an example of an application of a system of linear equations in two variables.